Okay, so the question was about turning in homework, and so the way it works with 161 homework, so here's the good news. The good news is that I sort of demand the TAs return to you graded homework a mere 6 days after you turn it in. And there's 140 people in the class, so that's, I mean, we should be grateful for the TAs for getting you feedback so rapidly. To help make that happen, what we ask you to do, and so this will start with homework number 1, which goes out today and is due in 8 days. We ask you to put each problem on a separate sheet of paper so that we can immediately kind of split it up and distribute it to the TAs so they can grade in parallel. And so then there's this, the question was about, it says don't staple them together. And that's just because they have to, you know, take them apart and you wind up getting staple cuts and stuff. So just use a paper clip, or, you know, in the worst case, if it's last minute, just, you know, fold the corner over and do something like that. So that was the question. Any other questions, logistical? All right, so there's 2 handouts, make sure you have copies. One is homework number 1, that's due in 8 days at noon. Remember, it's due hard copy in Gates in the 1B wing. There's a file cabinet there. The other handout is sort of about what kinds of solutions we're looking for. There's always this sort of, the first few weeks there's always this kind of feeling out period where you're trying to figure out exactly what rigor you should write down your proofs. You know, basically what happens is, you know, we give you feedback on the first couple homeworks and sort of mutual understanding of what's expected, but just to sort of speed up the process, handout 4 has a couple sample solutions to homework problems. Of what we're sort of looking for in your homework solutions. Okay? So what I'll talk about today is I want to start the discussion on divide and conquer. So that's the first of several kind of major algorithm design paradigms that we'll be talking about in 161. And we're going to begin with sort of the mother of all divide and conquer algorithms, merge sort. And I sort of feel like I owe you an apology, right? Because you're probably wondering, you know, in a 21st century algorithms class, you know, what are we doing talking about merge sort? You can't get much more old school than merge sort. But there's actually a lot of reasons to talk about it, not for a long time. I know it's review for almost all of you, but we'll talk about it a little bit. So first of all, it remains kind of pedagogically the cleanest introduction to divide and conquer. It shows you how clever divide and conquer algorithms can improve over more obvious solutions, in this case like insertion sort and selection sorts, quote unquote obvious sorting algorithms. It's also, you know, it's sort of review for most of you, and that's kind of by design, right? So that'll give you a chance to dust off some of the brain rust that probably accumulated over the holidays. On the other hand, you know, if some of you out there lecture sort of pretty difficult to follow, that may be a good and early signal that you're not yet at this stage of your education well prepared for the course. Okay, so the lecture will be fast, but again, I expect it to be a review, so I hope it will be easy for most of you to follow. And also, it's going to, you know, our analysis of merge sort will nicely kind of illuminate a number of the assumptions we'll be making about the analysis of algorithms in this class, and we'll talk about that sort of halfway through the lecture or so. Okay. And I guess the final reason is it'll segue into a much more general tool called the master method, which will be Tuesday's lecture, and that will in particular answer kind of in 5 seconds the questions we had about integer multiplication last lecture.